A dark fiber or unlit fiber is an unused optical fiber, available for use in fiber-optic communication. The term dark fiber was originally used when referring to the potential network capacity of telecommunication infrastructure, but now also refers to the increasingly common practice of leasing fiber-optic cables from a network service provider, or, generally, to the fiber installations not owned or controlled by traditional carriers. For capacity expansion, one reason that dark fiber exists in well-planned networks is that much of the cost of installing cables is in the civil engineering work required. This includes planning and routing, obtaining permissions, creating ducts and channels for the cables, and finally installation and connection. This work usually accounts for more than 60% of the cost of developing fiber networks. For example, in Amsterdam's citywide installation of a fiber network, roughly 80% of the costs involved were labor, with only 10% being fiber. It therefore makes sense to plan for, and install, significantly more fiber than is needed for current demand, to provide for future expansion and provide for network redundancy in case any of the cables fail. Many fiber-optic cable owners such as railroads or power utilities have always added additional fibers for lease to other carriers. In common vernacular, dark fiber may sometimes still be called dark if it has been lit by a fiber lessee and not the cable's owner. Overcapacity. During the dot-com bubble, a large number of telephone companies built optical fiber networks, each with the business plan of cornering the markets in telecommunications by providing a network with sufficient capacity to take all existing and forecast traffic for the entire region served. This was based on the assumption that telecoms traffic, particularly data traffic, would continue to grow exponentially for the foreseeable future. The availability of wavelength division multiplexing further reduced the demand for fiber by increasing the capacity that could be placed on a single fiber by a factor of as much as 100. As a result, the wholesale price of data traffic collapsed. A number of these companies filed for bankruptcy protection as a result. Global Crossing and WorldCom are two high-profile examples. Just as with the railway mania, the misfortune of one market sector became the good fortune of another, and this overcapacity created a new telecommunications market sector. Market. For many years incumbent local exchange carriers would not sell dark fiber to end users, because they believed selling access to this core asset would cannibalize their other, more lucrative services. Incumbent carriers in the U.S. were required to sell dark fiber to competitive local exchange carriers as unbundled network elements, but they have successfully lobbied to reduce these provisions for existing fiber, and eliminated it completely for new fiber placed for fiber-to-the-premises deployments. Competitive local carriers were not required to sell dark fiber, and many do not, although fiber swaps between competitive carriers are quite common. This increases the reach of their networks in places where their competitor has a presence, in exchange for provision of fiber capacity on places where that competitor has no presence. This is a practice known in the industry as competition. Meanwhile, other companies arose specializing as dark fiber providers. Dark fiber became more available when there was enormous overcapacity after the boom years of the late 1990s through 2001. The market for dark fiber tightened up with the return of capital investment to light up existing fiber, and with mergers and acquisitions resulting in consolidation of dark fiber providers. Dark fiber capacity is typically used by network operators to build SONET and dense wavelength division multiplexing networks, usually involving meshes of self-healing rings. Now, it is also used by end-user enterprises to expand Ethernet local area networks, especially since the adoption of IEEE standards for gigabit Ethernet and 10 gigabit Ethernet over single-mode fiber. Running Ethernet networks between geographically separated buildings is a practice known as WAN elimination. Emerging markets. In the last decade, many higher education institutions have bought up large quantities of existing fiber optics sitting dormant. Starting in 1999, Larry Smarr, a technology director from the University of Illinois, connected the Urbana-Champaign campus to major academic, research, and telecommunications facilities in the Chicago area. At the same time, other schools began creating large urban networks to directly connect their school campuses with hospitals and large telecommunications companies in metropolitan areas. Since then, the U.S. research and education community have been aggressively pursuing a revolutionary new means for delivering advanced networking capabilities. With the plummeting prices of fiber due to the overabundance, the option to own fiber networks has stomped out the competitive leasing of commercial circuits elsewhere. Experts say that a mile of dark fiber that in the past would have sold for $1,200, has sold for as low $200 or less. The downturn in telecommunications has offered significant savings to schools, since intercity networks may include several hundred to several thousand miles of fiber-optic cable. Variations: managed dark fiber is a form of wavelength division multiplexed access to otherwise dark fiber where a simple pilot signal is beamed into the fiber by the fiber provider for management purposes using a transponder tuned to the assigned wavelength. DWDM systems generally require central management because their closely spaced wavelengths are subject to disruption by signals on adjacent wavelengths that are not within tightly controlled parameters, especially if amplification is required for signal transmission over 100 km. Virtual dark fiber using wavelength multiplexing allows a service provider to offer individual wavelengths or colors, where access to a dark narrowband wavelength division multiplexing optical channel is provided over a wavelength division multiplexed fiber network that is managed at the physical level, but unlit by the network provider. This is typically done using coarse wavelength division multiplexing (CWDM) because the wider 20 nm spacing of the wavebands makes these systems much less susceptible to interference. Rate of expansion: according to Jerry Butters, the former head of Lucent's optical networking group at Bell Labs, Moore's law holds true with fiber optics. The amount of data coming out of an optical fiber is doubling every 9 months. Thus, excluding the transmission equipment upgrades, the cost of transmitting a bit over an optical network decreases by half every 9 months. The availability of dense wavelength division multiplexing (DWDM) and coarse wavelength division multiplexing (CWDM) is rapidly bringing down the cost of networking, and further progress seems assured. See also, dark fiber network, optical fiber, SFP transceiver, leased line, references.